Welcome everyone, welcome to Newton Gate Academy where we make your dreams come true. This is Saptarshi Datta and I am again back with another video of top 5 questions, but this time it will be based on current electricity, which is of class 12 level. So let us begin. So in the first question of the day, the question says that a wire of resistance 8 ohms is bent in the form of a circle. What will be the effective resistance at the ends of two diametrically opposite points? So let us try to find out what will be the resistance, or should I say the effective resistance. But before going to that, let us just draw the situation and then try to realize that what are the things that are in play here. Okay, so let us do it. So here there was a resistance. The resistance is of 8 ohms and the resistance is kind of bent to form a circular loop, something like this. So there is a circular loop of the resistance. Now the two diametrically opposite points, that is, here for our case we are considering it to be A and B. These are the two diametrically opposite points, and now we are putting a multimeter here. Suppose we are putting a multimeter here. So what we get? We get the effective resistance between these 2 points, and we have to find out what would be the result for this case. So let us now go to the details calculation. Now since we are considering this to be a circle, so can I say that for a circle, this length and this length is equal, which is simply equals to pi times r, which is the radius of the circle, right? So this is pi times r and this is also pi times r. So the length of this and this is similar, and we also know from the relation that r, or should I say, if I just write it like this, resistance r is dependent directly on the length of the wire or the length of the conductor itself. So can I now say that the resistance of this part and resistance of this part might be equal, or should I say they should be equal? Why? Because the lengths are equal. This length is equal and this length is also equal, and also the material is same. So the lengths would be similar, and hence there will be this resistance will be equals to this resistance. And so from this analogy, can I say that the total resistance of the wire has been divided into 2 equal halves? Why? Because the lengths are equal. And now can I say that the total resistance of the wire has been divided into 2 equal parts? That is, if the total resistance is 8 ohms, then can I say that the upper part is 4 ohms and the lower part is also 4 ohms, right? So the lower part is also 4 ohms, right? So the upper part is 4 ohms and the lower part is also 4 ohms. Now can you look at the picture and realize that this is actually for me a parallel combination of 2 resistors having individual levels of 4 ohms, right? So this is kind of a parallel combination of 2 resistors having resistance value 4 ohms. So what will be the effective resistance between A and B? It will be the effective resistance, or should I say the equivalent resistance for a combination of equal wires, equal resistances for the timing. Now let us try to calculate the resistance value itself. So the effective resistance, or for our case it will be the equivalent resistance. So the equivalent resistance will be something like this. So it will be 1 by R equivalent, and 1 by R equivalent equals to 1 by 4 plus 1 by 4, right? R equivalent will be 1 by 4 plus 1 by 4, because this is 4 ohms and this is also 4 ohms. And now let us calculate it. So the LCM will be 4 itself, and we have 1 plus 1. So we have 2 by 4 ohms. That is 2 by 4 ohms, which is basically, if I just do the division process, then 1 by half, which is 1 by R equivalent. R equivalent equals to 1 by half. Then what is the effective resistance, or for our case the equivalent resistance? It will be R equivalent, which is equals to 2 ohms. This is our required result. This is our required result. So in the next question, the question says that two conducting wires of same diameter are connected across a battery. Now, if the number density of electrons in the first wire is twice to that of the second wire, then we have to find out the ratio of drift velocities of electron in the two wires. That is what we are required to find out. So let us see how to calculate this one. Now, in order to find the solution for the question, what we need to do is that we first write the equation of current through the wires in terms of drift velocities and the other things. So let us first write that thing. So in terms of drift velocity, the equation of current, that is I, is something like this. Is I equals, we have N E, that is A, then we have the drift velocity, that is Vt. Drift velocity is represented as Vt. Now, according to the question, the wires actually are connected across a battery. Now, for simplicity, let us consider the battery is identical, that is one battery. Once it is connected with one wire and another time it is connected with another wire. So, for that case, can I say that this I value actually will be dependent on two things. Now let us consider the situation for the individual wires. That is, let us consider for wire 1 the current is I1, and for the second wire the current is I2. And let us write this equation accordingly. So we have I1 equals N into E into, this is N1, then E into A into VD, this is A1, right? And the second wire, for the second wire, I am writing it as I2, and I2 equals to N2 into E. Then we have A1, this is A2 actually, this is A2. Then we have VD. Vt is the drift velocity of the electron, but for this case it is different. So let us write this as Vt1, and for this it is also different. So let us write it as Vt2. Okay. Now let us try to dive a little deeper and try to understand what are the things happening here. Now in the question they also stated that the number density of electron in the first wire is twice to that of the second one, is twice to that of second one. So can I write it like this, that is, this is the number density for first wire and this is the number density for second wire, right? And according to the question, can I write this, that N1 is actually twice of the second wire. So N1 is basically twice of N2. Can I write this? N1 is basically twice of N2. And also the question stated that the wires of same diameter, and also this area of the wire is dependent on the radius, or to be more if I go according to the question, then the area is dependent on the radius of the wire itself, right? So can I say, since they have same diameter, so they have same area also, so or same cross sectional area also. So can I also write that A1 equals to A2, right? A1 equals to A2. Let me just write it clearly. Let me just write it a little clear. So this is A2. Now let us write the individual equations once again in terms of this and this. So let us just write that again. So our transformed equations are something like this. This is our first equation, that is I1 is twice 2 of N2, then E into A into VD1, and also I2 equals to N2 into E into A into VD2. Now here we have taken another consideration, is that since the wires have same diameter and also the cross-sectional area of the wire is actually dependent on the diameter, or to be more precise on the radius itself. So can I consider that if they have same diameter, so they have the same radius also, and they have same radius, then they have same area also, or should I say same cross-sectional area also. So we have taken also this consideration that A1 equals to A2 equals to A, and here are the equations. Now if I just try to take the ratio between these two, then what will be the ratio? The ratio will be something like this: I1 by I2, that is ratio between the respective currents. So I1 by I2, this is actually equals to twice of N1, oh sorry, this is twice of N2 actually, into E into A into VD1, and for this is N2 into E into A into VD2, right? These are the two, like the ratio between the two currents. Now this one we already know that since the battery is same, so can I say that this I1 and this I2 will be similar, or should I say they will be same? And if I take the ratio between I1 and I2, then this will be 1 itself, right? So now let us write the equation accordingly, considering only this part. So after this, can I write twice of, this implies twice of N2 into E into A into VD1. This is actually equals to N2 into E into A into VD2. Can I write this? Right? So, and from this N2 and this N2 will cancel each other, then E will cancel each other, and A will also cancel each other. And now can I write it like this, that twice of VD1 equals to VD2, twice of VD1, this is D actually, VD2. So twice of VD1 equals to VD2, and VD1 divided by VD2, this is actually equals to 1 by 2, right? This is actually 1 by 2, and hence can I say that from this, can I say this, that VD1 is to VD2, let me just write it properly, VD2, VD1 is to VD2 is basically equals to 1 is to 2, and this is our required ratio. This is the required ratio, or the ratio between the drift velocities, and this is the solution. Now the next question, the question says that a 5-volt battery of negligible internal resistance is connected across a 200-volt battery through a resistance of 39 ohms as shown in the figure. So this is the figure. Now in the figure, this is the 5-volt battery which is of negligible internal resistance, and this is connected across a 200-volt battery, and the resistance through which this battery is connected is of 39 ohms, and we have to find out the current through this resistance 39 ohms. So let us see how to find this out. So now according to the figure, can I say that the current for this 50-volt battery will be there also, and the current for this 24.200-volt actually battery will also be there. So there will be two currents, and the direction of the corresponding currents will be, for this the direction of current will be this, and for this battery the direction of current will be this also. So the direction of current is actually like opposite to each other. Like if I consider this to be I1 and if I consider this to be I2, then the direction of I2 and I1 is actually opposite to each other. And hence, can I say that the net currents between these two currents, that is the difference between these two voltages will be the net current here. That is the difference between these two currents will be the net current across this, or should I say through this 39 ohms, right? So let us try to go through that way and let us try to find out the net current through this. So for this I1, can I say that I1 is basically 5 volt divided by 39 ohms, and for I2, can I say that I2 equals to 200 volt divided by this resistance itself. So this is 39 ohms, right? So these are the two currents, and the net between these two currents is the net current through this resistance of 39 ohms. So let us find out the net current here. So the net current, that is I net. So net current will be I2 minus of I1. Why? Because I2 is greater. See, the numerator is 200 here, and here the numerator is 5 only, and the denominator is similar. So can I say that I2 is very much greater than I1, and hence I2 minus I1. So what is I2 minus I1? I2 minus I1 is basically 200 volt divided by 39 ohms minus 5 volt divided by 39 ohms, right? This is the net current. And if I do the subtraction, then can I write 39 will be the LCM. So 39, and this will take 200, and this will take 5 itself because the denominator is similar. So this will minus 5. So we have 195 divided by 39, and hence the net of the I, that is the net I net will be 5 ampere. This is 5 actually. So the net current is 5 ampere. So based on our previous analysis, can you solve me this problem? This problem is kind of similar to the previous one, but in this case, this negligible resistance battery is of 10 volts and the resistance is 30 ohms. So can you do this based on the previous analysis that we did in this video? Okay, please do this problem. This is for you, and comment your answer in the comment box. So in the next question, that says that an ideal battery of 4 volt and a resistance of R are connected in series in the primary circuit of a potentiometer. The length of the potentiometer wire is 1 meter and the resistance is 5 ohms. Now we have to find out the value of R, that is this R, for which it will give rise to a potential difference of 5 millivolt across 10 centimeter of the potentiometer wire. That thing we need to find out, that for which value of R this will be the potential difference. So let us see how to do it. So for the calculations, what we need to do is that first we have to find out the current through the circuit, and after that we are going to see how that current is changing with the length of the wire. So what will be our current in the wire? The current will be given by, let us suppose that current is given by I itself. So let me write I. So what is I? I is the potential difference, that is this, that is 4 volt divided by the total resistance. So what is the total resistance? We have one resistance as R and another resistance is this 5 ohms. So what is the total resistance? The total resistance is R plus 5 ohms. So here that resistance will also hinder the current flow here. So the current flow will be kind of hindered by the total resistance, and hence our I equation is R plus 5 ohms. This is the current equation in the circuit. Now we have to see this thing, that this 10 centimeter wire. Now the length here is actually 1 meter. See, the length here is actually 1 meter, and that 1 meter length is responsible for 5 ohms of resistance. So 10 centimeter of wire must be responsible for some kind of resistance there, right? So we have to find out that, or should I say, the next thing what we have to do is that we have to find out that how much resistance does this 10 centimeter or 0.01 meter of wire is contributing here. So let us try to see that, to find out that. So we have here this 1 meter is contributing 5 ohms of resistance. So let us write 1 meter of wire is responsible for 5 ohms of resistance. So what is my 10 centimeter of wire? That is 0.01 meter of wire responsible for. So 10 centimeter or 0.1 meter. So because 10 centimeter is equal to 0.1 meter, right? So 0.1 meter will contribute to 5 into 0.1, that is 0.5 ohms. So the resistance here will be, or should I say the resistance that this 10 centimeter of wire is contributing is 0.5 ohms. That this is the thing. Now we have to see what will be the potential difference here. So for that, what we do, we are going to use the same method and we are going to approach it from the same process only. So let us see how to do it. So what is the required potential difference here? The potential is 5 millivolt, or can I write this 5 millivolt as 5 into 10 power minus 3 volt. This is the potential difference. Now what is the current here? The current is similar, that this thing, that current is similar throughout the circuit of the potentiometer. So the current will be this. So according to Ohm's law itself, can I write as this voltage will be equal to this much current, that is 4 by this R plus 5, this much current, and into the resistance, that is this resistance, because we have to find out this is our given, or should I say this is our requisite condition, that this is the resistance here in our calculation. So let us just multiply this resistance as 0.5. Let us multiply this as 0.5. Now if I just go into deeper calculation and do the various things here, so let us do it. Now for this, can I say that this is basically equals to, if I just write the equation in a rearranged fashion, like this equation. This equation, if I just write it in a kind of rearranged fashion, then this will give something like this. That is this one. So let us just do the division process. So let me just cancel this 5 and this 5 and this 10 to the power minus 1 with one of these, and write the equation as 10 power minus 2, which is equals to 4 divided by R plus 5. 4 divided by R plus 5. Now again, if I just rearrange the equation, then it will give something, it will give me the R value actually, and if I just do the rearrangement process, then it will give my R value as 400, that is 400 minus this 5, so minus 5, which is basically 395 ohms. and hence this is the required value of R. So the next question says that two metallic wires of same material. So the metallic wires are of same material, but they have same length also. That is, they have same length also. But the difference is that the cross-sectional area is in the ratio of 1:2. That is this one. Cross-sectional area is in the ratio of 1:2. That is, this thing is different. Now, if these wires are connected in series, that is like this. If this is the one and this is another, this black is one and this blue is another, then they are connected in series like this. So, what will be the ratio of drift velocities of electrons in the wires? So let us see what will be the solution, or should I say how should we approach this solution. For this question, let us first write the equation of current in terms of drift velocities. So what is our equation of current? We have I is the current. So what is the current? Current is actually N into E into A into VD. Right? We write it like this. This is the current equation. Now, since the wires are connected in series, so can I say that the current in each wire is same? That is, if I consider I1 in the first wire and I2 is the current in the second wire, then can I say that these two will be equal because they are connected in series? So let us write this as I. Now the cross-sectional area is in the ratio of 1:2. So can I say that if A1 is the cross-sectional area for first wire and A2 is the cross-sectional area of the second wire, right? So can I say that A1 is to A2 equals to 1:2? This is what we are given, and from this can I say that A1 from this A1 divided by A2 equals to 1/2, that is half, or this implies that A2 is basically twice of A1, right? A2 is basically twice of A1. So now what we do is that we are going to write the current equation in terms of these things, that is this I and the cross-sectional area. So for the time being, I am writing two current equations. And since both the currents are equal, so I am considering both of them to be one I itself, that is I. So for the first wire, I will be N into E into A1 into V D1. And for the second wire, I will be N into E into A2 into V D2. But let us substitute the value of A2 as twice of A1 and write it as this N into E into twice of A1 into VB2, right? So these are the two equations that we are arriving. Now, if I just name this equation as equation 1 and let us name this equation as equation 2. This is my equation 2. So, can I say that both the equation, that is equation 1 and equation 2, are basically same? So we can equate these two equations. So let us just now do that. That is, equate these two equations and see what results do we get. So from equation 1, can I say that N into E into A1 into V D1, this is equal to N into E into twice of A1 into V D2. Now this N and this N will cancel each other. This E and this E will also cancel each other, and this A1 and this A1 will also cancel each other. and hence we are left with such a thing that VB1 equals to twice of VB2. And if I just now take the respective ratios between these velocities, that is drift velocities, then can I write VB1 divided by VB2 as 2 by 1, or can I write VB1 is to VB2 equals to 2 is to 1, 2 is to 1. That is the required ratio that we need to find out. So the ratio will be 2 is to 1. Now based on this analysis, that is the analysis that we just did, can you tell me that what is the case when the wires are connected instead of series, they are connected in parallel? Suppose they are connected in parallel. So can you tell me what will be the respective ratio of drift velocities of electrons in that case, that is when the wires are connected in parallel? Please comment your answer in the comment box. Let us see who gives the right answer first. And with this we have reached to the end of this video. Hope this video was helpful and you find this video helpful quite. And if you did find the video helpful, then please share this video with your families and friends, and also hit the like button and hit the red subscribe button of the channel. Okay, so see you in the next video. Goodbye.